So the law of sines and the law of cosines are actually at the beginning of chapter 6. We kind of have skipped over the chapter 5. But these things are a lot more similar to the solving of right triangles that we've already done in chapter 4. You definitely need to have done the inverse stuff that we did in the last lesson. But for the most part, they fit just as well with the end of chapter 4 than they do after chapter 5. And in any case, we always split up chapter 6, where we do sections 1 and 2 as part of the trigonometry unit. But then we pick up the end of that and package it with chapter 11, or not sure what's in this new textbook, if that's what they still call it. It's always dealt with differently. So we're going to use law of sines to solve what's called an oblique triangle. And by oblique triangle, we mean it's not a right triangle. Right? Both the law of sines and the law of cosines you use to solve not right triangles. Obtuse, acute, something like that. And especially when it comes to the law of sines, they have a proof of it in the back of the book. You can see where it comes up, how they come up with this thing. I mean, in the end, it uses right triangle trigonometry to come up with these equations. So because it's not right triangle trigonometry, we're not going to be doing any of this opposite over adjacent, SOHCAHTOA, any of that stuff, right? Nothing to do with that. What you are going to use, which is kind of familiar to geometry days, is you're going to use these combinations of sides and angles that you have to know. ASA, AAS, SSA, remember all those? SSS, what does SSS stand for? Side, 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 right? If you know 3 sides of a triangle, you can find the angles, right, using the law of cosines. If you know 2 angles and a side, you can find the missing angle and 2 sides. And it actually, what's the difference between when I write it angle, side, angle, and angle, angle, side? Bryce? Yeah, when you know the ASA, right, that means that you know 2 angles and the side that connects them, right? They're called included side. If it's AAS, what that means is you know an angle and you know another angle and then you know a side. But it's not a side that connects those two. But in this case, it's not going to matter whether it's the included side or it's the non-included side. We can figure them both out with the law of sines. Because after all, if you know 2 angles, how are you going to find the 3rd angle in a triangle? Subtract from 180, right? If you know 2 angles, you can always just do 180 minus. So you actually, if you know 2 angles, you rarely know 3 angles. And so you always have an included side, always. And the side-side angle, not to be written as angle, side, side, okay? So here's the law of sines. The law of sines, and it's the first thing about the way this is written is, if you label any old triangle like this, right? You can call the angles capital A, capital B, and capital C. And then the opposite sides are the lowercase letters. So that's where they're getting these A, B's, and C's from. Right? Across from the capital A is a lowercase a. Across from the capital B is lowercase b, lowercase c. So for any triangle, if you divide the length of a side by the sine of the opposite angle, it's a constant, right? The B over the sine of B, the C over the sine of C, all 3 will be exactly the same. Now, normally, you're not dealing with all 3 of those. You're just dealing with 2 of them at a time. But this is true, right? The side divided by the sine of the opposite angle is equal for all 3 angle side pairs. Now, you can flip those and get this version of the law of sines. If you just flip every one of these so that it's sine A over A, sine B over B, and sine C over C, then you get this alternate form. And usually it just depends on what you're trying to solve for. If the thing you're trying to solve for is a side, then you probably want to start with that because the side is in the numerator, the angle is in the denominator. If the thing you're trying to solve for is an angle, you want to do the one that has the angle in the numerator before you start. I mean, it just makes sense. And if you look at their triangles here, they have the H labeled. And the H is the height of the triangle, which goes from the opposite side, perpendicular line to the vertex. And that could be inside the triangle or it could be outside the triangle. It's still the height of the triangle. And that's actually, if you look at our formulas, either those or those, they don't even have an H in it, right? They don't. But they are used in the development of that. The H is important. And it does tell us something about the certain situations that we're trying to solve. The law of sines is, to me, it's way more complicated than the law of cosines, although the use of it, the actual formula is pretty easy, but the use of it is a little bit tricky. The law of cosines is totally straightforward when you use it. Okay, we good with that? Together? Good? Anybody? So we're going to do some of each of these, right? Of the angle, angle, side, angle, side, side, angle. And the first two are very straightforward. Angle, angle, side. So in this one, we know two angles and we know a side. That side does not happen to be in between the angles. That's why it's angle, angle, side. Now, the law of cosines, the law of sines, we need to know one angle and opposite side, where we know them both, right? Because that's going to depend on us having, one side of that proportion that you know both parts of it. So you always got to have like a side and an opposite angle. You know them both. And now you've got that as the opposite, as an angle. So what do you have to solve for first? You're going to have to solve for the side C, right? So if you're going to solve for side C, and you're going to be using B and angle B, then this is what we're going to use. We're going to use C over the sine of C equals B over the sine of B. That's the alternate form. I put the sides in the numerator because I'm solving for a side. Okay, now I can fill in for three of those, right? The only thing I don't know is the lowercase letter c. So I'm going to write c over the sine of 102 degrees equals b 28 over the sine of 29. Right? So the only thing you don't know is C, so solve for C. How will I solve for C? I mean, you could cross multiply, but why not just multiply both sides times the sine of 102? Cancel this denominator, you're done. Right? You could take a step and do that, now you still got to take one more step. So just multiply both sides by this sine of 102, you're going to get C equals 28 times the sine of 102 divided by the sine of 29. And that, you just put in the calculator. Clear. So 28, first make sure you're in the right mode, degrees. Second, clear. 28 sine 102 divided by sine 29. 56.5. C equals 56.5. C equals 56.5. Okay. Now, what else do we need? We're going to need to know the side A, but to know side A, we need angle A. How can I find angle A? Subtract from 180, right? We probably should have done that one first, right? So this angle A is 102, that's 131, so that's 49. 49 degrees. In fact, let me write it there. 49 degrees, which is 180 minus 102 plus 29. And so what's the last thing we need? Side A. So again, now we definitely are going to have A over the sine of A on one side, and then you can pick, because now we know two side and opposite angles. So you could either do B over B like that, or you could do A over A, or C over C, because you have that. How about I'm just going to do this one over again. I'll just say this is A over the sine of 49 equals 28 over the sine of 29. And multiply both sides times the sine of 49. So 28 sine 49. Make sure to close that off, divided by the sine of 29. 43.6. People get that? Have you tried it? Pretty straightforward. That was an angle side. And this one, this is an example of angle side angle, but it's actually done as a word problem here. If you notice, here's our triangle that we're looking at. Oops. It says a pole tilts toward the sun at an angle of 8 degrees from the vertical and casts a 22-foot shadow. Right, there's the 22-foot shadow. The 8 degrees with the sun means, or sorry, with the vertical. This is the vertical, and this is 8 degrees. The 8 degrees is right there. That's actually not the angle we need. We need this angle. What is this angle? 98, right? You have to add the 90 to the 8, so it's 98 degrees. And let's see, the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So remember, what do angles of elevation and angles of depression have in common? They're with the horizontal, right? So the horizontal line is here. The angle of elevation is 43 degrees. Okay, how tall is the pole? So they're asking us to find this right there. Right. This one didn't say find all the missing sides and angles. We actually only have one thing we have to find here. Well, let's see. In order to use this, we need to know one angle and opposite side. Let's see. We know that angle, we know that angle, we know the included side. We need to know that angle before we start. What is that angle? Or how will we find this angle? You're going to subtract, right? So this angle is 180 minus 98 plus 43, which is 141.39. 39 degrees. Is that right? Okay. Because I'm subtracting minus 98 minus 43. It's in parentheses. Okay. Okay, so now we have one side in opposite angle. We need to find that side, so we're going to use that side divided by sine of 43 equals that divided by that. All right, so we're using this. Sine, A over the sine of A equals, are these labeled? Yes, they are. C over the sine of C. So that's A over the sine of 43 degrees equals 22 over the sine of 39. Solve for A. $23.8. You okay with that, CERN? Good, good, good. No. Okay. Now, gets more the side-side angle is very complicated. Like I said, when we get to the law of cosines, you see, there's none of these complications when it comes to the law of cosines. But this is just part of doing these problems here. There's many possibilities when it comes to a side, when you know two sides and a non-included angle. And these are just if the angle is acute. Right? There's another slide for obtuse, so that's a fairly easy slide. This is the one that's a little more tricky. And so every one of these, when they show us this, side angle, they're using angle A and side B and side A. And that is side angle, right? So that is just the way they're always going to do that. I mean, they could have used different ones, but this is the standard right here. Now, if you can imagine that these are known quantities, right? If the angle A is here, and you know the length of B and the length of C, you don't know the length of A. You do know that it's going to be along that dashed line somewhere because you know how much the angle opens up. If this side right here is less than the height of the triangle, that means that there's no way it'll ever reach to the opposite side. So you cannot have a triangle in some cases if that side A is too short. Okay. If the opposite side, the A, is actually the same as the height, well, then you got a right triangle. Then there's one solution, and then you've got it there. If the side opposite is greater than the B, then you can extend that. It'll definitely intersect with that dashed line, and you will know, you'll be able to solve for a triangle. There's one triangle then. Where it becomes tricky is, let's say that I know the angle, and I know this side, and I know the A, but the A is less than B, but it's more than the height of the triangle. Then you could actually conceive of two different triangles. You could have a triangle where this side A is to the right of the height, which means that's an acute angle, or you could have that same length of side reach to the bottom by going to the left of the height. And so there's two different triangles. One of them, angle B, is obtuse. One of them, it's acute. So we actually have two triangles. So that's the issue with the side angle. There's the possibilities are you could have no triangle, you could have one triangle, or you could have two triangles, just depending on the lengths of the sides and the value of the angle that they gave you. So in this one here, it says, for the triangle in the figure, we're going to get to the next page, A is 22, B is 12, and A is 42. Find the remaining sides and angles. So let's see, which case does that look like it's going to fall under? It's an acute angle, 42 degrees. And it looks like the A is bigger than B. So which one of those does it look like? This one right here, right? A is greater than or equal to B. So that's, we expect that there would be one solution. And I didn't copy the figure, but that's fine. We'll just draw our triangle. Well, I'm gonna draw it like this. We know it's going to be an acute angle. So this angle is 42 degrees. The A is 22, and the B is 12. Right? Find the remaining sides and angles. Okay, which is the first thing we have to solve for? It's always the first thing you solve for in one of these. You say that was A, that is B, and that is A, which means this is B and this is C. What do we have to solve for first? You're going to have to find angle B, right? You know this angle and side, right? So that'll be one side of the proportion. And on the other side, you're going to have to solve for angle B because you know that the side length, the opposite side length is 12. So we're using this right here. The sine of B over B equals the sine of A over A. Fill in for the things that you know. Sine of B over 12 equals the sine of 42 over 22. So the sine of B equals 12 sine 42 over 22. So put that in the calculator. 12 sine 42 divided by 22. I'm getting 0.36498. I'm gonna round it to 3 decimal places for now. 0.365. Now, is it possible for the sine of an angle to be 0.365? What are the values of sine? What is the range of the sine function? -1 to 1, not the inverse, right? Not the domain, right? We're just talking the sine function varies between -1 and 1, -1 and 1. So there's no problem with that. How do we find B if we know the sine of B is 0.365? Right? Sine B equals 0.365. How do you solve for B? You divide by sine? Come on, please. You can't divide by the letters SIN. What was the homework on last night? There's like no point teaching you something if you can't extend it one day. How do you solve for the angle when it's inside the function? Use inverse. B equals the sine inverse of 0.365. Second, sine inverse, 0.365. 21.4 degrees. Okay, so this one is 21.4. Okay, now that we know 2 of the angles, we can find the third, right? The third angle will be 180 minus those 2. $116.6. And then we can find the remaining side, which is side C. Right, so we're going to use C over the sine of C equals, and you could take your pick for what's on the other side. I think I'll do the A and the sine A because I've actually already got those over here. So this will be C over the sine of 116 0.6 equals 22 over the sine of 42. So notice when we had to find the angle B, we used the form of the law of sines where the angle was in the numerator. But here, when we're looking for side C, we use the form where the side is in the numerator. Right? We pick the one that works for us. So C equals 22 sine of 116.6 divided by the sine of 42. I'm getting 29.4. Seems about right. I mean, one thing, what I just looked at right there is does this seem right in terms of, is the biggest side across from the biggest angle here? I mean, the 116.6 is the biggest of the three angles, so that better be the biggest of the three sides, and it was. I mean, is the smallest side across from the smallest angle? Yeah, 12 is across from the 21.4. So it seems like it's ballpark okay. Okay. Let's see. Here's a no solution case. And you could see we got our acute angle. A is definitely less than B, which means we could either be in this case, right? A is less than B, which we might have two triangles, or we could be in this case if the A is less than the H. Now, for the most part, I don't ever mess with the H. There's no reason to have to mess with the H. I'm just going to set up my triangle and try to solve it. And as we solve it, we'll see why there's no solution. Without having to do this separate calculation of H, you'll just see what it is. So let's see. I think I've got a slide for that. So here's my triangle. A, B, C. A, B, C. So the A is 85. The A is 15. And the B is 25. So again, we're gonna have to use the sine of B over B equals the sine of A over A. Sine of B over B equals the sine of A over A. Right, the sine of B over 25 equals the sine of 85 divided by 15. Solve for sine B. Sine B equals 25 times the sine of 85 divided by 15. So let's figure that out. 25 sine 85 divided by 15. 1.66. Again, is it possible that the sine of an angle equals 1.66? No, because the sine is between -1 and 1. That's how you know there's no triangle. Just solve it. If you get to the point where you get it something like that, which is not possible, then you say it's not possible. There's no triangle. And now we get to the two solution case, what they call the ambiguous case, right? So we've got our angle, and we've got the B is 31, and the A is 12. So the A is less than B, which definitely it could either be here or here, but this is going to be one that actually works out that um, it's over here and there's two. So let's see what that looks like. And these are the answers right away, just to see what we're talking about here. That if for the three values that we were given, A, B, and angle A, you can form a triangle with that length of a side of 12 going to the right of the height of the triangle. That in that case, it's an acute angle. Or that same length here, you know, if you swing it to the other side, it would still form a triangle and would look like this. So those three values don't necessarily give us one triangle. There's two different possibilities with those exact measures of the sides. So that's what we're looking at here. This is where we're going, but I just wanted to show it right there. We didn't change it. In both cases, the angle is the same, side B is the same, but the side A is the same. It could either be here and reach to the other side of the triangle, or it could be over here. In one case, B is acute, in one, it's obtuse. So let's see what that looks like when you solve it. So draw my triangle. Probably need 2 slides for this. A, B, C. A, B, C. A is 12. B is 31. Angle A is 20.5. And as always, we're going to have to solve by doing the opposite side, or solve for angle B. So I'm going to say sine of B over 31 equals the sine of 20.5 divided by 12. So the sine of B equals 31 times the sine of 20.5 divided by 12. Okay, 31 sine 20.5 divided by 12. 0.9047. Which means angle B, which is the sine inverse, second sine inverse, second answer, 64.8. 64.8 degrees. Okay, now here's where you end up with your two triangles. If the sine equals a positive number, which two quadrants could it be in? And now we're not talking about inverses, the stuff in the homework class tonight. We're just saying, if you look at the coordinate plane there, and I'll draw a circle over the top of it, which two quadrants is the sine positive? 1 and 2, right? If the sine equals 0.9047, 0.9047 is somewhere up here, right? This is 1, so it's a little bit less than that. Well, sine could have that value and be over there, or it could have the same value and be over here, right? Sine will have that same positive value in quadrant 1 or quadrant 2. In this case, it's an acute angle. In this case, it's an obtuse angle. So the way you've got to figure that out is like this. Once you get the 64.8 as the possibility for that angle, what you're going to do is you're going to check if this angle here is 64.8, then if there is another triangle, what is going to be the value of this angle? Well, it's going to be 180 minus 64.8. Right? This angle here is the same as this angle here. So if I subtract minus 64.8, then I'm going to get that value right there. So we go ahead and do that. That is 180 minus 64.8, which is 115.2. Yeah, 115.2 degrees. So then you need to check. If that angle is 115.2 and you add the angle A that you already know, is it less than 180? Is 115.2 plus 20.5 less than 180? And the answer is yes, it is. There's your two triangles. If you added it together and it was more than 180, that means there's only one triangle. That's the check. So in this case, we're going to say the two possibilities are this angle is 64.8 or that angle is 115.2. And so you're going to have to solve it twice. You know, I think, no. All right, so let's start by making it 64.8. 64.8. And then we're going to have to, now we can find the angle C, right, at 180 minus 180 minus 20.5 plus 64.8. $94.7. And then we have to find the angle, the side C, right? And the side C will be C over the sine of 94.7 equals, and now we could pick either one we want. I'm going to pick this one here, 12 over the sine of 20.5. So C equals 12 sine 94.7 divided by the sine of 20.5. $34.2. And then we're going to have to repeat the process. And this time, we're going to, instead of using 64.8, we're going to use 115.2. Same process. Let's see if I can do this. I think what I'm going to do is like this. Edit, copy, edit, paste. And I will erase everything down here. And make that smaller. Got to take that out of there. Of course, the triangle doesn't look right because it's not obtuse, but I think everything else looks pretty good. So now our angle C is 180. Oh, first let me write in 115.2. And angle C equals 180 minus 20.5 plus 115.2. $44.3. So that is 44.3. And now we need to find side C. C divided by the sine of 44.3 equals 12 over the sine of 20.5. Sine 12. 23.9. All right, if I go back, let's see, I had the answers up there. Well, they just had the angles. They didn't fill in the other sides, but okay. So that was the one, 64.8. That was the other, 115.2. And I can delete that now. Okay, if the angle is obtuse, right? If you know the lengths of these two sides and you know the angle, then you don't know what this side is, but you know it extends along that dash line. And there's two possibilities. If the A is less than B, that means it's never going to reach the third side. So there's no triangle if A is less than B. If A is greater than B, then it will, and you'll have one triangle. Right? If the angle that you got is, I mean, you ought to be able to know that. If you see your angle is obtuse, then if A is less than or equal to B, you say no triangle. You wouldn't even have to solve. What would happen if you tried to solve? You would get sine equals a number bigger than 1 or less than -1. That would be what it looks like. So this is application of law of sines. The course for a boat race starts at point A and proceeds in the direction south 52 degrees west. Well, let me do something here. Edit. Cut. Edit. Paste. I didn't notice that it had done that. Okay, this is a one piece of section 4.8, which we need to address because it comes up even later in chapter 6. And that is the idea of bearings. If you sail, Pierce, you may deal with bearings that, people when they're navigating, when they're trying to give their direction, are going to give it in terms of how many degrees to the east or to the west are you from a straight north-south line. And it's written like this. N or S at the beginning tells you, is it going to be with respect to a south line or a north? And then the number of degrees it is to the east or the west. So south 35 degrees east means straight south 35 degrees to the east. Right. North 80 degrees west means you go north and 80 degrees to the west. That's the angle that they're talking about. Right. North 45 degrees east. So they're going north 45 degrees to the east. It's just a way of giving you an angle. Okay, so now we'll go back to this picture. Okay, the course for the boat race starts at point A. It goes in the direction of south 52 degrees to the west to point B. Then in the direction of south 40 degrees to the east. And finally, it goes back to point A as shown in the figure. And point C lies 8 kilometers directly south of point A. So, we know that this is exactly north-south line right there. Approximate the distance of the race course. So, obviously, we're going to use the law of sines. And we need to find the lengths of, we know this side, but we need to know this side and this side so we can add them up and have it all. Well, if we only know one side, we need to have two angles. Right? How can I figure out an angle that we don't already know here? I mean, we need to know either this angle or we need to know this angle. We need two angles in that triangle. How can we figure that out? Okay, this is where your geometry comes. That's why we teach you geometry before we teach you pre-calculus. These are parallel lines. This is a transversal. These are these are consecutive interior angles. What do you know about consecutive interior angles? I'm not saying this angle, I'm saying this whole angle right here. What about these two angles? Are they equal? Do they look like they're equal? So if they're not equal, what are they? They're supplementary. They add up to 180. So you know that this angle and this angle add up to 180. Okay, well, what's 180 minus 52? Yeah, this whole angle there is 128 degrees because of consecutive interior angles, which means how much is just that part which is inside the triangle? 128 minus 40, right? So this is going to be this part only, right? That P is 88 degrees. So often in these kinds of problems, you're going to have to do some geometry to try to spread angles where you know them. Okay, now if that's 88, we should be able to figure this angle here, right? That'd be 180 minus 52 and 88, which is what? Say again? 40? Looks right. 40 degrees. Okay, so now we can find side C and side A. We'll have to take 2 steps, but we can find that. So the side A will be A over the sine of 52 equals, and we could pick either, we have to pick this one, 8 over the sine of 88. So A equals 8 sine 52 divided by the sine of 88. Put that in your calculator. Divided by sine of 88. And I'm getting 6.3. Yeah, could I use Pythagorean theorem to find the other side? No. Why not? Not a right triangle, right? So you just have to solve for that third side. So now we can find the side C. C over the sine of 40 equals 8 over the sine of 88. So C equals 8 sine 40 divided by the sine of 88. And that looks like 5 point, I'm just going to round it to the tenths, call it 5.1. But that wasn't the question, right? They didn't say solve the triangle. They said how long is the race course? So now how do I know the length of the race course? Just add them up, right? A plus B plus C. A plus B plus C equals 8 plus 5.1 plus 6.3. And that is 11.4, 19.4. Okay. So I left a blank there, but I don't need that anymore. So that's okay. So again, we learned about the law of sines as a means to solve oblique triangles. It's in 3 cases. We still have 2 to go. And I'm sure when you see the law of cosines, although the formula is more complicated, it's actually much easier to apply. You don't have the ambiguous case, right? There's no 2 triangles. And there's rarely a time when you have no triangles. I mean, it's possible. So these are the homework problems.